Hello everyone, welcome to the ninth tutorial class on artificial intelligence. In this class, we shall discuss about a very important topic of artificial intelligence, which is fuzzy set theory, or you can call it as fuzzy logic or fuzzy logic controller. Okay, so to understand how a fuzzy system operate, we need to understand basic of fuzzy set theory initially, and after that we shall discuss about different kind of membership function and their corresponding feature in this class. Now coming to the first slide, the question arises, what is fuzzy logic? So basically fuzzy logic is a computational paradigm of AI that is based on how humans think. Most of the cases our human brain can reason with uncertainties, vagueness and judgment. That means whenever we think or interact with other person, we always think or talk with certain amount of uncertainties. That means whenever we ask anyone, how are you? He will answer, hey, not good, I'm fine, like this. That means there is lots of uncertainties or vagueness in its judgment or in its talk. Okay. However, computer can manipulate only precise value like true or false or 1 or 0. So fuzzy logic is an attempt to combine these two techniques. That means it will balance between our human reasoning and computer reasoning. So fuzzy logic looks at the world with imprecise, unclear, vague or uncertain terms in much the same way that our human brain takes in information. Okay, like temperature is so hot or not so hot or cold or not so cold or extremely cold, like this. So these are the some linguistic variable where lots of uncertainties are associated with it. That means we cannot just say that this is hot or this is cold, that means either 1 or 0, but we'll tell some intermediate use, we shall use some intermediate term like not so cold or extremely hot, like this. Okay, so fuzzy logic mainly deals with this vagueness, imprecise or unclearness. Okay. Now coming to the an example, like consider a person known five number of student or five number of person like Ankit, Rajesh, Santosh, Kavita or Salman. So if I ask him that is that person honest, so the person can give this kind of answer like he is extremely honest, he is very honest, he is honest at some time, or he is extremely dishonest, like this. So you can see that whenever we tell that he is honest at honest at time, that means there is lots of uncertainties or vagueness in his honesty. Okay, so basically this fuzziness or these uncertainties is nothing but fuzzy. Okay, so fuzzy logic mainly deals with this kind of problem where there are lots of there are lots of vagueness are associated with the data. Like yeah, you can see that this if we called it as a crisp answer, so for the crisp answer or the for conventional set theory, the answer will be in either yes or no, true or false, 1 or 0, like this. However, in case of fuzzy, the answer will be like maybe, may not be, absolutely, partially, etc., or extremely, like this. Okay. So coming to the crisp versus fuzzy. So crisp logic is conventional set theory. Okay. So conventional set theory mainly deal with either 1 or 0, true or false, like this kind of element. Okay. Wherever fuzzy logic is based on the theory which is a generalization of the classical set theory. Okay. In next slide we'll see that crisp logic is a generalization of fuzzy logic. Okay, classical set are also called as the clear set because the answer will be clear, like 1 or 0, true or false. But in case of fuzzy logic, the answer will not clear. There are lots of vagueness. But in real world, we always prefer fuzzy logic for better understand or better description. So our world is better described with fuzzy. Now coming to the history of fuzzy. So fuzzy logic is first proposed by the Zeda in 1965, and was applied in steam engine control by Mamdani in 1974. However, fuzzy logic became very popular or practically implemented in Japan in 1990 in automation. Okay, so that's the history of fuzzy logic. Now, fuzzy logic application, basically, fuzzy logic system or fuzzy system is very popular because its development and its implementation is very simpler, and it does not require any kind of mathematical model. Okay, only a practical understanding of the overall system behavior is necessary. And moreover, fuzzy logic system give a higher accuracy and smoother control of the overall system as well. So these 3 points will be elaborated in the upcoming classes gradually. Okay, now coming to the some application of fuzzy logic. So you can say that fuzzy computer has been used in 16 station subway system in the Japan. Okay, so so that the ride is become very smooth and rider do not need to hold straps. Okay, and by Nissan, famous company, it use fuzzy automatic transmission, fuzzy anti-skid braking system in its vehicle. Hitachi, whereas Hitachi use or CSK use handwriting recognition for the fuzzy logic by using fuzzy logic. Sony used fuzzy logic for hand printed character recognition. Hitachi again used fuzzy logic for the voice recognition. And very interestingly, NASA recently used fuzzy control for the autonomous space docking, and where simulation shows that fuzzy control system can greatly reduce the fuel consumption during the automated space docking. Okay, and later Canon developed autofocusing camera where they use fuzzy logic control for this purpose. And moreover, in washing machine, fuzzy logic control is almost becoming a standard feature because depending on the weight or load or the dust sensor, corresponding wash cycle has been controlled. So for the smoother control, we need to use fuzzy logic. Another thing like controlling the AC. So whenever we temperature control of AC, air condition, so here fuzzy logic can be implemented there for the smoother response. However, to understand the fuzzy logic system like temperature control by air condition or the wash cycle controlled by the washing machine or the others fuzzy logic control system, we need to understand first fuzzy set theory and its associative properties, arithmetic operation, rules, etc. first. So initially we will start with the fuzzy set theory, then we will go through different kind of inference rule, fuzzifier, defuzzifier, okay, and ultimately we'll discuss a real life fuzzy logic control system for your better understand or clarity. Now fuzzy set. So to understand the fuzzy set, we need to revise the concept of crisp set initially. So consider the entire population of India, okay, which is denoted by X, and H is given by the all the female population, and all the female are denoted by the a set where H1, H2, H3 are element for this female population, and M denote the all male population where M1, M2, M3, Mn uh, are the element of the corresponding male population. Okay, so if we draw it using the Venn diagram, so this one denote the universe of discourse given by X. Okay, and this universe of discourse consists of two part. One is uh, female population part, and another is male population. So it consists of element of male, sorry, female, and it consists of element for the male. So the this set is consist of M1, M2, M3 up to Mn, and it consists of H1, H2, H3 up to HL. Okay, you can see that these two set, these two set do not overlap with each other. They are independent with each other. Okay, so this kind of set is known as the crisp set. So either one person like H1, it either belongs with H1 or it belongs with the M1, any person. Okay, so so as the two set do not overlap with each other, so one element cannot occupy two set. Okay, so all more so such type of set are called as crisp set, and where all sets are consist of finite number of individual which are independent with each other. Now coming to the fuzzy set. So consider a students of IT department, which is where subject code is 60108. Okay, so X is denoted by that. So that is the universe of discourse. And next, S. S denote all good student. Okay, so we define another variable or set that is given by all good student. Now consider in IT class there are students like Rajat, Kavita, Salman, Ankit, etc. So question arises, how can we define the goodness of a student? So to define a goodness of student, we use a parameter which is known as the membership function that measure the goodness of student. So S set or S fuzzy set can be given by an ordered paired, which is given by S element of good student, and there is another variable which is already told that is known as the membership function, that is that denote the membership of goodness or amount of truthness, you can call it as. Okay, like a student may be very good. Okay, so its goodness can be given by like maximum goodness is zero point 0.9. Okay, so suppose if we consider that DGPA or CGPA of a particular student, so by observing corresponding CGPA you can clearly say that this student is either good or bad. If we consider the fuzzy logic, sorry, key split, so the student will be either good or bad. But here we consider all the students are good, but their goodness is measured by some kind of variable or function that is known as the membership function. So you can say that if Ankit is topper, so his goodness is most. So we can say that its value can be given by zero point 0.9. Okay, and like Salman, if he is the odd student, so its goodness will be very much low, that is given by zero point 0.1, and in between them Rajat and Kavita lies like zero point 0.8 or zero point 0.7 their goodness. So basically this is given by, this is nothing but fuzzy set. So where fuzzy set given by ordered paired of element and its membership function show that belongs to X. Okay, so here crisp versus fuzzy set. So you can see that this one given by mathematical expression S equal to element S, where that is S belongs to X, and fuzzy set given by F ordered pair of S comma mu, where S belongs to X, and mu is given the membership function or the degree of goodness or degree of membership of S. Okay, and it is a collection of element, you can see that it is a collection of elements. So capital S is collection of small s. Okay, like uh, this one, like capital H consists of small h1 individual female, and capital M, this set is consist of individual female, sorry, individual male, and this consists of individual female. So it's a collection of element, whereas in case of fuzzy set it is ordered pair, that means it consists of element as well as the another function that is known as the membership function. Okay, so inclusion, next point is inclusion of an element. Okay, inclusion of element S belong belongs to X into S is crisp, that is, it has a strict boundary, as you already told that this set are independent with each other. That means all the element of the H within lies within this boundary. That means they will not overlap with each other. Whereas in case of fuzzy set, uh, we can say that all element belong to all set, but depending on the degree of membership. Okay, so inclusion of element S belongs to X into F is fuzzy. That means if present, then with a degree of membership. Okay, uh, now coming to elaborate this conclusion, or crispet and fuzzy set with another example. So consider 2%, and we want to uh, express them using crisp logic or fuzzy logic. Okay, so point is, question is that is either he is tall or not. Okay, so if you consider fuzzy logic, so in case of fuzzy logic, the sorry, in case of crisp logic, the answer will be one, answer will be only two, like it is either tall or not tall. Okay, so so you can say that, consider that this one is the 0 feet and this one is the 7 feet. So if it greater than 5 feet, so we can call it as the tall, and if less than 5 feet, so we can call it as not tall. So either one person will either tall, and if he is less than 5 feet, that will be considered as not tall. So for tall, the corresponding for membership function will be 1 point, and for not tall, the membership will be 0. So that is the crisp logic. So either, answer will be either 1 or 0. Okay, true or false. But if we consider the fuzzy logic, okay, so in that case, we'll tell like this, that he will suppose this person has height of 6 feet, so we'll tell like this, that definitely a tall person. Okay, so for 6.5 feet, the we can say that the corresponding membership or corresponding tallness is like mu equal to 0.95. Whereas if the person, if this person has height of 4 feet, so you can say that really not very tall at all, but with membership function 0.3. So you can see that here the output is tall or not tall, but here we can say that all person are tall, but with some kind of membership function 0.95, 0.30, and all the membership function will lies between within the range 1 and 0. So you can say that from these two example, you can say that a crisp set is a fuzzy set. Okay, where value of membership function can take either 1 or 0, but whether a fuzzy set is not necessarily crisp set. You can say that for this crisp fuzzy logic, the corresponding value of the membership function is 0.95 and 0.3, that lies between 1 and 0, but it can take 1 or at 0, but it can take other intermediate value between 1 or 0. So you can say that a crisp set is fuzzy set, but a fuzzy set is not necessarily crisp set. So you can from this example it is clear to us. Okay, so this one is the membership function plot. If you plot height along x-axis and degree of membership of mu along y-axis, so you can get this kind of graph. Okay, so this is the membership graph. Now coming to the technical definition of membership function. So uh, if x is a universe of discourse and small x belongs to x, then a fuzzy set A in capital X is defined as a set of ordered pair, that is A equal to A equal to x comma mu a x, that so that x belongs to capital X. Okay, so ordered pair, that means x, small x denote the element and mu a x denotes the membership function. So mu a x is called membership function for the fuzzy set A. Okay, so mu a x means what? Membership function of the element x for the set of A. Okay, so x map each element of x into a membership grade or membership value between 0 and 1, both inclusive. That means it can take 0 and 1 also. Again another example, if we consider, or if we want to express the city of comfort with respect to all cities in India, so we can express the fuzzy logic for the city of comfort like this. So that there will be ordered paired, where first one denote the element, that is means some kind of city, and the comfortness can be expressed by the corresponding membership function of that city. Like for New Delhi, the corresponding comfortness is given by zero point 0.7, for Bangalore zero point 0.9, Chennai zero point 0.8, Hyderabad zero point 0.6, Kolkata zero point 0.3, like this. So you can see that the membership function is maximum for Bangalore. That means city comfortness for the Bangalore is maximum, whereas comfortness for Kolkata is minimum. Okay, so that is the example of another example of fuzzy logic, fuzzy set. Now coming to the discrete and continuous MF, at the name suggests, uh, if we plot the membership function with respect to its element. So if the value take the discrete value, obviously that will be the discrete membership function, and if the value is continuous with respect to its element, so that will be a continuous membership function. So you can see that this one is the discrete membership function, and this one is the continuous membership function graph. So a membership function graph can is nothing but membership value versus its element. Okay, so you can see that if we consider the like young, b equal to young age, so if we plot from 0 to 60 age, and you can say that 30 is the young age, so you can say that the corresponding membership function will take like this shape. Like for 30, the membership value will be high maximum, but if it slightly less than or slightly greater than 30, so it will be also young but not so young, so its membership value will be gradually decreasing. So it can take like this value, whereas this one is nothing but a discrete example of discrete membership function. Now properties of membership function. Now, first one is the support. So, what is support for a membership function? The support for a membership fuzzy set or membership function is nothing but where mu a x greater than 0. So, you can, if you plot the consider the membership function, so the region where the membership function become greater than 0, that is nothing but the support area. So, this one to this one, that is nothing but support. But here the value of membership function is 0. So, we should not consider the support for this area. Now core is the area where its membership value is 1. So you can see that for this type of membership function in this area, the value of mu is 1. So this one is the core. Okay, so core a equal to x, where mu x equal to 1. Now we know the core and we know the support. Support means where mu does not equal to 0. Core means where mu a equal to 1. And the boundary, so boundary means where mu a lies between 1 and 0. So you can see that this one is the boundary from this area to this area, or with this area to this area. This is nothing but boundary. So boundary means it lies between 1 and 0. So if mu 0 greater than mu less than 1, so that is the nothing but boundary. Now next one is the normality. So normality means a fuzzy set A is normal if its core is non-empty. Okay, so we can see that here no value of membership function can uh, take um, membership value of 1. So we can say that normality of A is false. Now support, sorry, next one is the crossover point. Now crossover point of fuzzy set A is nothing but where where a line crosses, or sorry, a crossover point of phi set A is a point where x belongs to x at which mu equal to zero point 0.5. So you can see that this one is the corresponding membership function, and this point denote the mu equal to zero point 0.5. So if we draw a straight line from here, and there will be two point that cross the membership value, so those point are known as the crossover point. Fuzzy singleton. So what is singleton? A fuzzy set whose support is a single point in x with mu equal to x is called the fuzzy singleton. So but you can see that uh, this graph consists of whose sub yeah, whose core is this one, that means where mu equal to 1, but this one is not singleton value, or following fuzzy set is not example of fuzzy singleton. If all are removed, then obviously that will be a singleton, fuzzy singleton. Now alpha cut, strong alpha cut. So it is a property like uh, A alpha will be given by the alpha cut of fuzzy set A is a crisp set defined by A alpha, where x equal to mu A x greater than alpha, greater than equal to alpha. And the strong alpha cut is defined by similarly A alpha dash paired of x, sorry, element capital X, so that mu x greater than alpha. Okay. Now different kind of membership function. Now we shall discuss different kind of membership function. For the most of cases, we use triangular, trapezoidal, Gaussian, Bell function, and sigmoid function. So by using so this is the triangular membership function. The shape of the membership function is like triangular, and it has three parameter, and which is given by this function. So by controlling a b c, we can change the shape of the triangular function. Now coming to the trapezoidal. So trapezoidal, the shape of the trapezoidal membership function is given by is like this. So for the this is known as the trapezoidal, and there is four control parameter a b c d. By controlling them, so you can control the shape of the corresponding membership function. Okay, it's like first point is the A, where the start, where the trapezoid function start to rise. B is the where the it reach maximum, like this. Okay, and next one is the Gaussian function, which is given by C and gamma, and it can be defined by using this function. So the shape of this function, Gaussian function, is like this. And this one is the Bell function, and Bell function is generalized Bell membership function, has three parameter and given by this equation: 1 by 1 plus x minus c to the power 2b by a. Okay, and another is one is the sigmoid function. So sigmoid function has 2 points, so c is the crossover point and a is the slope. By controlling c and a, the slope or slope can be changed, and sigmoid function can be given by 1 by 1 plus e to the power 1 plus e to the power minus a by x minus c. So by controlling a and c, you can control the shape of the parameter. Apart from these four conventional um, conventional membership function shape, uh, we can use others function also, like step function or linear function or non-linear membership function for for describing different membership. So that is depend on us. Now coming to a example, so consider the following grading system for a course. So marks, if less than equal to 90, so you will consider excellent, and if it lies between sorry, it is wrong, so marks greater than equal to 90. Okay, very good. If 75 greater than equal to marks and less than equal to 90, that is very good, and that is good, average, poor, bad. So you can say that these are the linguistic variable, where that means these are the, there are lots of fuzziness. Okay, so if you want to express this all this variable using fuzzy logic, so we can use this kind of membership function like this. So if we don't use any kind of fuzzy logic, so if you use the crisp logic, so you can say that for bad, we can say that if marks less than equal to 35, that is bad. So for crisp logic, that will be simple is rectangular shape. That means if it is less than bad, yeah, I think drawing is not proper. Okay, so you can say that bad means where the bad lies, that means if it less than 35, that is bad. Okay, sorry. So this one basically 35. So you can say that bad, poor, average, good, very good, excellent, all can be expressed in term of this kind of function. Okay, like Gaussian or trapezoidal, like this. If we consider the very good, like, so if it lies between what is the definition of very good? 90 and 75. So 90 and 75, that is very good. Okay. So that means this point, if it beyond, if we reach beyond the 90, that means that will be not very good, but it will be under excellent. Okay. So this one is the good, for the good corresponding membership function is like this. So coming to the conclusion, so just in this class we have discussed the concept of fuzzy logic and its application, and the most important part is the of fuzzy logic is the membership function, and it define the degree of truthness or degree of membership for a particular fuzzy set that belongs particular set. Okay. And moreover, we also discuss different kind of features and others type of membership function that can be used to represent a fuzzy logic. Okay. Or fuzzy set. Okay. Now there is a difference between fuzzy and probability. Fuzzy means what is the amount of certainty in the corresponding fuzzy set, and probability means that the chance of event to occur. The reason behind it's to mention that both can take the value between 1 and 0, but fuzzy and probability are different. Probability, that means the chance of an event to occur, but here there is no event to occur, but we want to calculate the corresponding certainty of a particular thing or particular language or particular term, that is the fuzzy. These are the references. Thanks.